Everyone. In this session, we will be revising Chapter 7, Sound of Class 8. This we have already discussed in the class. Let us recapitulate all the topics which we have already done. So let's start. What is sound? Sound is a form of energy that produces the sensation of hearing in our ears, right? So we do hear different types of sound. Sound of a bird, sound of vehicles, different sound, musical sound, all these. So each source of sound is a vibrating body. So we can say that the vibration produces the sound. If the body is vibrating, it produces the sound. For example, here you take a string. I have taken a rubber band and cut it into a string and stretch that string. Keep its one end in your mouth under the teeth and the other end in your hand. So when you pluck the string from the middle, that means from this point, you can see that the string starts vibrating. Okay, and you can able to hear a feeble sound. Feeble means a very weak sound, but yes, of course, you can able to hear a sound. Right? So we can say that any vibrating body produces the sound. Next, sound is produced due to vibration. So let us understand this with some examples. So here we know that sound needs a medium, right? Without medium, it cannot propagate. So we can say that it cannot travel through a vacuum. Sound cannot travel through vacuum because it needs a medium, right? So here we have a source of sound. Suppose when a source of sound is vibrating, it is creating some periodic disturbance in the medium near it. What type of disturbance it will create? The disturbance will be like this. See, the condition of the medium changes actually. What disturbance means? Whatever is the condition of the medium, it starts changing. And the disturbance then travels in the medium in the form of waves. Okay, so see here how it will be. So this is known as rarefaction. Here, what is happening? The particle of the medium are far apart. Whereas the compression here, the particle of the medium are close. They're coming closer. Again, they're far apart. Again, they're closer. That means it is moving to and fro. So this to and fro is nothing but produces the vibration. And ultimately, vibration is nothing but produces the sound. Okay. So this is all about how the sound actually propagates in a medium. Next, we have some important terms related to the wave. Let's see what are they one by one. Amplitude. What is amplitude? It is the maximum displacement of the particle of medium on either side of its mean position. Okay. So for example, I will draw a wave like this. This is a wave. So here, this is the amplitude. This is the mean position and this is the extreme position. So this displacement of mean to extreme position is your amplitude, which is represented by small a, and its SI unit is meters. Next, what is the time period? It is a time taken by a particle of a medium to complete one vibration. It is denoted by capital T and its SI unit is seconds. Next, what is frequency? It is the number of vibrations produced by a particle of medium in 1 second. That means in 1 second, how many number of vibrations can be produced by a particle? Okay, it is represented by letter F and its SI unit is hertz, or simply you can write HZ. Next is wavelength. It is the distance traveled by the wave in one time period of vibration of particle of medium. So even this figure, if you see this distance, the distance between two successive trough or crust is also a wavelength. It is represented by lambda and its SI unit is also meters, same like that amplitude. And we have a relationship between this time period and frequency, that is frequency is equals to 1 upon T. That means they both are inversely proportional, right? Next. Representation of a wave. How can we represent a wave? So let's see this one. We can represent a wave. First one is the displacement time graph. Okay, so let me draw here a wave. So this is the time period on the x-axis. This is time t in seconds. And this is the displacement in centimeters. Okay, so this is the amplitude, children. This is the amplitude. This is the time period, displacement time graph. So here this shows the variation of displacement of a particle of the medium with time at a given position when a wave propagates through the medium. So this is called the displacement time graph. So here the amplitude is represented by A, as I have shown in this, and the time period is capital T. Okay, that means if we consider this figure, so here this is the amplitude plus 2 and this is minus 2. This is 2, this is 4. These are the timing. So from this what we can conclude, the wave amplitude of wave is 2 centimeter and its time period is 4 seconds. So the frequency will be what? 0.25 hertz. Okay. Similarly, we have displacement distance graph. So same almost this graph is also same. This is the amplitude plus 2. This is minus 2. This is also displacement in centimeters. And this is the distance, right? Here we have to write distance x. This is in meters. So this is your amplitude. And this is the lambda. The distance between two crust or trough is the lambda. That is nothing but the wavelength. So this shows the variation of displacement of particles of the medium at different positions with distance at same time. So here the amplitude of wave is shown by symbol A and the wavelength is lambda. Here, so this is how we can represent the wave. Next. Characteristics of sound. What are the characteristics? So let's see this. Sound wave is actually characterized into 3 types: loudness, pitch, and quality. So in this session, we will be talking about only the loudness, okay, in detail. So what is loudness? It is the characteristic of sound by virtue of which a loud sound can be distinguished from a faint sound, both having the same frequency and same waveform. Okay, so here, children, loudness actually depends upon the amplitude of vibration. More will be the amplitude, more will be the sound produced. So let us understand this in a better way. See this example. So here in this, 2 wave diagrams are given, one producing soft sound, another is producing loud sound, right? So here the amplitudes are different. Suppose this is 2 centimeter and here it is 4 centimeter. So their amplitudes are different, but their wave pattern, both are sinusoidal wave, that means sine wave pattern, right? And their frequency is also same. Here also we have 3 hertz. So this is, suppose this is one complete wave, this is 2. So this is 2 hertz, this is also. So frequency is same, quality is same, only the amplitude is different. Okay, this is clear. Next. In the next, we have the factors affecting the loudness of sound. So let's see what are these factors one by one. First one is on the amplitude of wave. So how does the amplitude of wave depends? Okay, so see here, more the amplitude, more the loudness. They are directly proportional. If the body is vibrating with greater amplitude, it will send more amount of energy, and hence it will receive the energy received by the eardrum will be large, so it produces louder sound. Next is the distance of the source of sound. If the listener is very close to the source of sound, he hears a quite louder. But if he is far away from the source of sound, he will hear a very feeble sound. Okay, so here it is. We can say that closer the source, louder is the sound. Next, on the surface area of the vibrating body. So a large vibrating area sends forth a greater amount of energy. That means the amplitude of vibration will be large if more will be the surface area. So, you know, that's the reason in temples you must have noticed that a bell with a big case producing very louder sound than with a very small case. That's the best example. Next is sensitivity of the listener. Yes, the loudness of the sound actually depends on the sensitivity of the ears of the listener. So for some people, these loud sound is not very good. I mean, it is very it becomes noisy for them, but for some it is not noisy. So depends upon the sensitivity of the listener. So a given sound may appear to be loud to a listener, but not so loud to the other listener, right? So it depends upon that. So we can say that the loudness is actually directly proportional to the square of its amplitude. Okay, let's see this in the next slide. Here we have relationship. What is the relationship between loudness and amplitude? So this relation only, that is loudness is directly proportional to square of its amplitude, right? So here the same figure. Here we have two waves. These are the amplitude, suppose 2 centimeters, and this is suppose 3 centimeters. Okay, this is the displacement, and these are the time. So see here, children, the amplitudes are different. This is the amplitude in the first case, and this is the amplitude in the second case. Of course, in the second case, the amplitude is more, so the loudness is also more. Next, how can we measure? What is the unit of loudness? It is measured in decibel. Like we can say that 1 decibel is equals to 1/10 of bell, where bell is the unit of level of loudness. So this is actually named after the scientist Alexander Graham Bell, okay, who has actually invented the most useful device like telephone and all. Clear? So we have a different level of sound produced by some objects. Like if we talk about the safe limit, what is a safe limit? This also we have discussed, no? Safe limit of sound of hearing is from 0 decibel to 80 decibel. Up to this limit, we can able to hear it properly. I mean, smooth sound. And the sound of level 10 decibel to 30 decibel. So this is soothing sound, soothing sensation. And if it is 120 decibel and more than that, it can cause headache. Then it becomes noise actually. Clear? More than 120 hertz. So this is what you need to remember, the range of the limit of the sound. If it is 0 to 80, it is a safe limit. From 10 decibel to 30, it is a very soothing sensation. And if it is above 120 decibel, then the sound actually becomes a noise. Okay, so this is all about the loudness. This is one of the characteristics of sound. We have other two characteristics also that we will discuss the next video. That's all for this video. Thank you.